name is ShreshthaKulkarni, and as part of the final project in CSC594, I have attempted knowledge extraction from Wikitext. Here was to find statements that show relations between two entities. So X is a form of Y, that kind of relation, and to build a classifier to sort out good examples from bad. The dataset I used for this was comprised of 60,000 articles scraped from Wikipedia, and it is available at the link shown here. The process of knowledge extraction involved various steps. It started with text cleaning, so HTML cleanup, like cleaning the JavaScript and CSS, then removing the XML tags, HTML specific characters like AND, NBSB, and N-dash, and then removing structured data like info boxes, categories, tables, because the problem statement stated as such. We also removed text that came under headings like see also, references, or external links. Those were only links to other articles or other web pages, and they were not important as part of the relation extraction. This was followed by tokenization and part of speech tagging. The next major step was named entity recognition, and I used the any chunker from NLTK package for this process, and I also utilized the annotations that were already present in the text. So some of the entities were actually annotated with double square brackets or triple apostrophes, so I parsed them, and then I marked them as any directly. Then this step was crucial for the next step, which was extracting the relevant sentence segments which show the relation between two entities, and I utilized the regex parser from NLTK package for this purpose. This was followed by feature construction and classification using the naive Bayes classifier. The most important step in this project was relation extraction, and as I stated in the previous slide, I used the regex parser from NLTK package for this purpose, and I constructed grammar patterns to extract the patterns like X is a Y, or X is a type of or form of or kind of Y, where X and Y are two entities. Like, for example, CIA or Central Intelligence Agency is one entity and Virginia is one entity. Then we could say CIA is located in Virginia. So is located in is the relation that we are looking for. The other patterns that I attempted was X was described by Y, or X was some sort of verb by Y, then X some action followed by some text and followed by the entity. For example, X died at this spot, then X followed by some text, as a followed by some text and followed by the final entity. Then sentences which gives a list of things. For example, X owns a list of properties, like where the individual properties are the individual entities, and then X, then some text, then Y, some text, then Z, where Z is an entity which elaborates either X or Y. These are some of the examples of the sentence segments that were extracted from the parser. So you can see here the entities are actually enclosed in the square brackets. So The Day the World Went Away is a song by 9 Inch Nails. So 9 Inch Nails is the group that maybe sang the song which was named The Day the World Went Away. Centriole is a cylindrical shaped cell structure, again similar kind of pattern. Then the next one is the pattern where we see X, some text Y, some text Z. So Brewer was nominated by President Chester A. Arthur to the United States Circuit Court. And the other one that is of interest is the one that gives a list of things. So Murillo is represented in Prado by around 40 paintings, some as celebrated as the Good Shepherd, the Holy Family with the Bird, and the Immaculate Conception. So these three entities are equivalent to the paintings that Murillo painted. So this is the kind of relation that we are looking for. This was followed by another major step, which is the feature construction. So the segments that were extracted from the regex parser were visually examined, and then I came up with the following features. For example, whether the segment starts with an entity, it's a true or false feature. Whether it ends with an entity, because in some cases the sentence was actually ending abruptly, so this feature tried to capture that. Then what was the starting entity, what was the ending entity, were there any other entities beyond the entities at both ends, how many words occurred between entities, what was the total length of the segment, did it include a verb, what were the number of words in starting entity, what were the number of words that started with a capital word in starting entity, and similarly in ending entity, what were the number of words in ending entity, and what were the number of capitalized words in ending entity. Based on this, I constructed a naive-based classifier to perform the final task of evaluating sentence relevance. So the segments that were extracted were marked relevant or irrelevant by hand, and I did this for 500 odd segments and then divided them into test and train sets, and the final model was evaluated on accuracy, precision, and recall. So the table here provides the final data. So I came up with a final accuracy of 69.56%, and the precision of the no class was 76 and the recall was 72. Similarly, the precision of relevant class was 65 and the recall was same as well. This slide lists some of the learnings or future improvements that could be done to the project. So first and foremost, we saw that the accuracy, although was satisfactory, had a lot of scope for improvement. The data also showed some signs of overfitting. For example, the precision and recall value for the Y class were almost identical, but I feel that adding more labeled sentences would have helped here because we really had very less data for the relevant class. But the most important thing that I feel could be done here was improving the named entity recognition, because a lot of time it was felt that the named entities were actually a single entity was actually separated into multiple entities because the chunker was not able to identify it properly, and the adjective part of the name, for example, Central Intelligence Agency, the part central is actually an adjective and it was separated as an adjective, and the rest of the part, like Intelligence Agency, was actually termed as the named entity. So if we could improve such identification, that it would help a lot. And we could also I could also see later that there were other annotations that were used to define, that could be used to define named entities, and if we could create a dictionary of these named entities and utilize them to annotate the repeating words, then it would help us identify the named entities correctly. We could also try to use some other any chunkers, for example Stanford any chunker, which has shown better success than the one that is available in the NLTK package. Then there were instances when the entity was either preceded or succeeded by another entity, and it would really make sense to evaluate if it was actually a single entity or multiple entities. Then the feature extraction could also be improved. For example, we could relate to the words that are either appearing before or after an entity. We could see for the presence of some W WH words like WH, adverb, what, when, where, within a short distance of the sentence ending to see if actually the sentence is incomplete. And finally, creating a response feedback loop from the classifier and if we can so as to decrease the human labor of labeling the sentences, then it would have really helped in terms of utilizing the complete data set that is available to us. Finally, conclude, I would say knowledge extraction is very difficult. Text is generally messy, and so the cleaning is of supreme importance. The cleaner the text, the better you would be able to identify the segments. And but however, the most part or the most effort that went into this project was in the segment extraction and labeling the sentences. If we could automate that process somehow, it would have really sped up the project and really improved the performance. I hope you enjoyed the presentation. Thank you.